So I hope my screen is visible. Yeah, guys, just tell me again, my screen is visible now. Good evening, guys. Good evening. Hi, hello. Hello. Guys, am I audible? Yes? Okay, thank you. So, guys, once again, I welcome you all to the data visualization with Python's workshop. So, yeah, this is a 3 hours workshop, and we have everything. We have one link that is called documentation link. The link is there in description box. You all can use this link and save it somewhere for your future reference. We have everything mentioned there. Everything is stored there. That all the notes that we are going to teach in the session, you can refer it anytime. There is an enrollment link and session link, also the step-by-step process by which you can like how to mark your attendance, how to submit your assignment. Assignment is not there for this session, but yeah, like how to generate your certificate. Every step is mentioned there, and this is a notes page. Here, every note is stored. Like wait, it's loading. Yeah, till then I will go ahead, and this is our student ambassador program page website, and here we have a SAP program like a student ambassador program. The batch is starting from 1st March. The date is mentioned wrong here, but the you can enroll for the program before 29th Feb, and also you can get many benefits from this like program. Like we have incentives, we provide exciting swags, we provide our like workshops to attend, and also you get a chance to meet industry leaders, and also like you get coupon swags, everything, and also you get a big chance to like work with us like Let's Upgrade team. So yeah, guys, and also it's beneficial for your CV and LinkedIn profile and everything. So you can enroll for this, and you can join the SCP community. There you can contact the admin directly and get to know everything about this program. And also, please guys, make a note that this batch is starting from 1st March, and we have successfully completed many previous batches. So yeah, you can go through this page. And guys, I think the page is loaded. Yeah, now in this page, every notes is mentioned, everything in detail we have stored here. You can save it and refer it for your future reference. And this is here we have attendance link. In this attendance link, you can click on this link and you will be redirected to this page. And I have not enrolled for it, so I will enroll for it quickly. It's taking time. Yeah. So guys, I don't know what the issue is now. After enrolling the page, you will get after enrolling here, you can see this attendance option. Mark attendance option. Here, click on this toggle. Now see, you will get this rate, like how much you like the session. You can mark it according to yourself. Then we have a feedback column, like you can give your feedback according to yourself, what improvement you want from us, or what thing you like from us. You can submit it here, and then reload your page. If this progress bar, yeah, reload the page. If when this progress bar will increase, here you will get mark certificate option. So yeah, you can download the certificate after 8:30 from this link. and see my progress bar increased. So after 8:30 we'll get the general certificate option from here. And also we have community, WhatsApp community, Telegram community. You can join us there if you have anything, and we send every update, everything you can get from there. So I will just call our trainer for today, that is I will stop sharing my screen. Yeah, there our trainer, Megha Sham sir. He will guide you. He will be there with you for next 3 hours. He will teach you, and he will teach you the data visualization using Python workshop. He will be going to take. So hi sir. Hello sir.
Yeah, hi Anam. Hi all. I think it's audible
Hi.
to everyone.
Yeah, sir, you are audible. So sir, can you give brief introduction about yourself and what are we going to learn in this 3 hours workshop?
Yeah, sure. So, good evening, students. Hope everyone have a good weekend and we'll try to have some knowledge sharing sessions. So, this is Megasham here. So, I'm working as an ML architect view in Judge India Solutions, currently located at Delhi. So, basis for data analysis and even for the data science perspective. So, for multiple domain wise, especially for manufacturing and healthcare fields. So, I've been into and even direct interactions with the heads and relatively practice heads and with the sales perspective and even a part of LetsUpgrade as a trainer session wise. So even for workshops and relatively with data science upcoming trends and the technologies which have been upcoming view and format of Microsoft and other cloud services as well. So I've been into perspective wise. So this is about me. We'll be trying to learn relatively for data visualization. So using our Python programming language and even a tool wise, I'll try to display. So especially multiple tools which I've been using in the industry standards and how we can able to take it for a kind of real-time data set. So I'll try to share it. So we'll be learning. So not to worry. So be cool and we'll start our sessions as well. So I think Anam, we can start out, right? Yeah.
Yeah, sir, I will leave and I will hand over the session to you. So bye guys, bye everyone, bye sir.
Yeah, yeah. Thank you. Thank you, Anam. Okay, let me share my screen. So just a second. Okay, so yeah, guys, I think it will be visible. Maybe if it has been delay in the sharing the screen, so it will be taking time to load. So meantime, we'll try to start with our kind of explaining about this data visualization, why we are trying to learn about this data visualization, especially. So if you see in a real-time field, if you're in industry standards or even if you have been passed out and some have been searching for jobs and so on, right? So main thing is like data has been more can say like an extensive kind of researchable, you can able to say, and we can able to give a kind of survey, right? So it's a meaning of survey only. So for visualization is kind of research and survey you can able to say. So it's like for technical as well as for non-technical people, we can able to explain them, especially in a business perspective and so on. So there we can able to relieve and how we can able to make that business growth and how this trends and the seasonalities and kind of upcoming views which we can able to showcase and we can able to give it in our projects also. Right. So it might be for that's what I was mentioning about the college students and so on, right? Colleges or even industry standards. So anywhere for a particular project or POCs. So this visualization concepts will be much related, especially when they are in the opposite of non-technical people. So business perspective wise and so on, because everyone cannot be a technical. Some might be in different fields, but as per the business wise, they want to know about it, how they have been growing and how we can able to use it, and it might be any terminus, right? Fine. So related to this visualization concept, so there are a few kind of you can say like libraries or kind of analysis we can able to make it, and determining how we can able to use that influence. I mean, you can use that influences and using that terminologies and so on. We'll try it out, especially for I have one data set which have been in the current organization, so kind of sample data set which have been taken. So that will be much relative, and we can able to use it out, especially in the manufacturing industries. Okay, so that have been taken into. So normally we used to learn like it might be for graphical representations, or it might be a kind of pictorial view where the data will be real, right? So always the data would be a kind of a real concepts, right? So the truth will be coming out, so that we can able to understand a kind of historical information. Okay, so let's say for example, how many number of people have been coming into this live sessions. So I want to analyze it out also. That is also kind of analysis, right? So we can able to analyze. It might be based on their education perspective. It might be based on the age. It might be based on their background, and relatively it might be from industry standards. So we can able to segregate them, and we can able to analyze who has been more relative for this particular concepts and so on. Right, this is also kind of analysis, right? So even if I say like any industry, if you're trying to go and you're trying to as a in this field wise, especially for this data analysis field wise, so they'll be knowing about their business, and they want to know how the growth would be, and how we can able to analyze, and how we can able to add it into their field, right? So it might be from client services, or it might be from product services, or it might be from any different team wise or department wise also, so that we can able to gather, and how we can able to represent. So representation is more important, right? So you might be knowing that concept, but how you will be representing into the front end view to the client, and it might be for any particular employees or people and so on, right? So that's common for each and every one interactions only, right? So that's what we are trying to learn it here, so as a how this analysis we can able to break through, and we can able to make it go forward and so on. So that's a kind of a view we can able to learn it here. If you see normally, if you say like past years, right? So many things like beyond 10 years back and all. So normally they used to do in a point of through Excels, right? So if I think you will be agreeing with that. So many of them will be doing their visualization through Microsoft Excels itself, right? So that's the charts and all. We used to give that interaction view and so on. Right, that is more relevant view. So it was being handled, and we can able to specify it out. So right, so that's a way of mentioning how this is being interacted and viewed. Right. So now these kind of visualization tools, how we can able to handle, and how we can able to add it to the data perspective. So that we'll try to check it out. Before that, we can able to segregate those visualization concepts also. Here you can see like it might be a kind of numerical interaction of data, or it might be a kind of repeated data kind of things, and even that we represent as a categorical view. So there are different stages and different charts or representation we can able to add it into, and we can able to segregate as easy as possible. Right. So because some numerical kind of data will not be much suitable for a particular differentiation and or kind of designs and so on. But for kind of any text or even for categorical information, so we can able to differentiate that. Right. So especially for this, let's say normally you might have been heard of pie charts and so on, right? So pie charts will be more numerical kind of percentage wise. That will be adding as a differentiation view, right? So it depends on their how we can able to add, and how we can able to segregate those stuff and so on, right? So it depends on the particular differentiation. So those are the main view we can able to say. Right. So fine. So according to Python view, right? So these are most commonly used tools, or you can say like in libraries or packages and so on. Especially for visualization, this Matplotlib and Seaborn have been commonly used one. But for a kind of analysis to use it for a particular data, this NumPy libraries, SciPy, Pandas, Scientific Learn for machine learning. So those have been required also. It's not been The meaning that only these visualization with Matplotlib and Seaborn or even Plotly or any other kind of bottle kind of view libraries will be used. Beyond that, there are many tools which are a kind of cloud-based tools which have been available also. It might be from Tableau, it might be from Power BI, right? So it depends. But as per the Python packages wise, when you try to enter, these are the more relevant, you can able to say much relevant features which have been, you can able to use it out. And it depends on the scenario also. It depends on that every time only these libraries I can able to take it and so on. So there will be some advanced libraries which will be coming by also. Maybe with Matplotlib as a kind of basic wise starting view, you can able to take it. But later on, we can able to add that with some attached kind of libraries or attached kind of functionalities also we can able to add it, or even Seaborn. Right. If you see this for this, especially for SciPy, so as per the consideration, SciPy mostly for you can say for statistics, you can able to use it out for this SciPy, right? And we can say like in how relatively this histograms and how we can able to differentiate that particular scenarios and so on. So this SciPy will be much related also. And even for NumPy, if you consider mainly for a kind of data interaction with the arrays, normally the how the data, numerical kind of data, we can able to segregate like mathematical concepts. So these arrays will be much related. And even for pandas also, you can able to take it, a kind of data frames. Right. So data frame is nothing but a kind of tables. If you have been not into this particular library, Python and so on. So I just give it as a simple meaning of it. So just a table wise, how the Excels would be looking like. So this pandas library, you can able to use it and we can able to segregate that into a readable format. And is scientific learn. So we saw it as a sklearn. Many of them have been into technical wise and especially for machine learning and this even with data analysis. So at that time, this sklearn will be much relevant and so on. So these also would be much useful at the time of predictions and so on. So when you do that model building, but most of these three relevant, you can select NumPy, SciPy, and Pandas would be much required, especially for handling a data. All right. So because every time the historical information of the data, when you're trying to look into, it will not be full and crystal clear wise, and some might be not available. I mean, kind of the data will not be present also. So we need to handle that particular data. So how we can able to handle that, and relatively how we can able to modify that particular data, or you can able to expand that particular data in a meaningful way. So these and all libraries will be much relevant. Libraries are nothing but packages which have been already created and stored into one particular functionalities, right? So this will be much relevant also. And visualization already have been discussed. So Matplotlib and Seaborn. So this library, you can say like Matplotlib is from the MATLAB. Many of them might have been sort of this MathWorks and so on, right? So those company wise, many of them have been used. So they have been taken and created in a one particular library format itself. And Seaborn also, it's a kind of advanced kind of package which have been entering into, right? So these have been much relevant wise. So we'll be, you can say like we'll be using that these libraries and we'll try it out applying those stuff and how we can able to integrate and so on. Okay, fine. So let's just- fine. So I think we'll try to do in this thing, like even practically wise, we'll try to check it out. It's not like fully theoretical wise, only the understanding we are trying to see and so on. We'll try to apply and see in kind of coding wise. So you'll be able to specify it how to use that particular library, how to can able to integrate that particular libraries and so on. Okay, so we'll be learning in practical wise also. So let's see it here. Okay, so fine. So already I've been specified about these relevant libraries as such. So we'll try to do a kind of data. So we'll try to take it at data wise and we'll try to apply and check it out how relevant those data set should be, and relevant those how we can able to visualize, and you can select scattering, and even with providing some kind of interface and so on. So that will be much relevant wise when you try to apply into the coding perspective. So if you see many of the companies, even if you enter into giant companies, I mean giant IT companies, or even for startups and so on, many been trying to look into, it might be freshers or it might be experienced wise also, searching for a good data analyst, and even with kind of multiple tools wise, especially the cloud tools wise, and even with these libraries who have been good into hands-on experience also, right? So you will be agreeing with that, right? So we will be um, entering into that way. So there we will be having that good relevant usage of these particular libraries. So I'll try to make it that you can follow me, and then we'll try to do some relative stuff. Okay, so you can just come into this ways, right? And even this installation of these libraries and all not required. Okay, so already if you have been using this Jupyter notebooks or any particular ID editors and so on. So you can able to use those libraries as it is. So they have been like default installed ones, right? If you want to install, you can able to install it out also. And I'll show that kind of installation, how you can able to do it, especially in Jupyter as well as in the other editors like VS Code. Mostly I'll be fond with the VS Code and so on, but I'll try to show it how we can able to add that into perspective wise also. So normally you might have heard these words like EDA, exploratory data analysis, right? So I think many of them might be heard these words and so on. Right. So do you agree, if you have been agreeing that, so these have been much relevant in your maybe if you have been searching for jobs, and if you have been as a fresher or if you have been experienced, you might be using this kind of technical stuff. All right. So do you agree with that? If you agree, just give it in the chat, yes or no. Right. So this is this exploratory data analysis mainly for historical information, right? So your historical, like previous data. So just let me give one example. Okay, so one of the reputed bearing manufacturing company. Okay, so it was a very good bearing manufacturing company. So bearing itself, you might have been heard. So it will be like bearing metals of your truck bearings, and even with this low motive vehicle bearings, and even with the railway bearings and so on, right? So that is their business. Okay, so they used to what they'll do is like in the manufacturing industries, these bearings will be passed and they'll be having some stages, and due to some high heating and so on, they'll mold that bearings, right? So what happens when it's trying to get molded, you will be getting the shape, right? So you'll be getting some size, so where the customer will be requiring that particular size as their requirement and so on, right? So these and all, they'll be having the data information, so we say it as a PLC data. Okay, so normally PLC machines will be present, so PLC data would be required. So it contains all the how much is the bearing size, and how much is the bearing weightage, and how many we are getting it as a good size of the bearings and so on. These data and all you can able to get it. Okay, so as a business perspective, you're having your machines and you're getting the data. Okay, fine. But what is the relevant feature of this particular data analyst will do with this particular data itself? So what they'll do, what they'll try to do. So they'll be knowing about how much bearings have been passed into that furnace, right? And how many have been getting good bearings as an outcome from the machines, and how many have been as a productivity you can able to find out the outcomes, so how many good and how many have been defective kind of bearings. So these and all like kind of historical information, right? So I mean, from if they have been working for 5 years or 10 years, so they'll be having that behind like almost 10 years of data, which we can able to represent, and we can able to showcase to their clients perspective. So this is my background of my company, I mean bearing company and so on, and we can able to showcase their productivity, how much we got it, and this is a machine we have been used, this is the data we have. So this and all we can able to represent, right? So for a non-technical person, they can able to identify easily. So they can able to see that, okay, through this representation, so I can able to view that, okay, this many bearings have been passed in this particular year or in this particular month, how much customers have been coming by, and what is the size of the bearings they have been used. Commonly, some commonly size will be there, right? So that relatively, so this is all like kind of historical data, so we can able to use it out also, especially for this data analysis. That's what exploratory, so we are trying to explore, we are trying to think beyond that, right? So we are trying to think beyond that information. Okay, fine. So yeah, so we'll be showing, we'll be using the Jupyter notebooks. I'm just checking the chat, so some have been trying to ask relatively, right? So okay, fine. So what I'll do, so I'll try to take into this Jupyter notebook itself. So we'll enter into the kind of practical sessions, right? So, but now these are the main libraries, especially for the data analysis perspective. Okay, so these libraries will be much relevant, and further we'll try to use it out. I'll not take it into a kind of very much basic of having some NumPy array and so on. I'll take it into a data set and then we'll apply it out. I'll try to mention what kind of data it is, but it's real-time data only. It's not a kind of any Kaggle data and so on. So I have been with the manufacturing industry, so I'll take a sample data, especially so um, we'll try to understand in that way, right? So that will be much relevant also. Okay, so just give me a minute. So I'll try to open my Jupyter notebook. So we'll try to look into and we'll try to apply some useful concepts. Okay, so just give me a minute. So I'll try to share my screen with the Jupyter notebook. Let me open that. Okay, so many of them okay, fine. So many of them might be using the Jupyter notebooks. I don't, if anyone like new to that, so I'll try to mention what is the usage. It's just like kind of a kind of where programming stuff we can able to use it out in a kind of notebook we can able to say. Okay, so they have their capabilities to install and use much kind of packages in a easy way. Okay, so this is one of the you can say like notebook wise. So it's a Jupyter notebook, and it's from Anaconda Navigator. So some might be heard of the word of Conda. Okay, so Conda is a common keyword normally in the terminals and all we used to use it out, right? So there we can able to use it. And even if anyone has been fond of their IDEs like VS Code or Spiders, they can also able to use that and directly what and all if I'm trying to apply the same thing, they can able to do it in their respective VS Code itself. Okay, so it's not specific, so we can able to use any particular IDEs and so on. Okay, so for now I'm trying to go with the Jupyter notebook. So I just opened it here. So let me create a new one. Okay, fine. So I think my screen is visible. Okay, meantime, if you want, you can open your Jupyter notebooks also and you can uh, take it. So let me, I hope I'm clear till now, right? So about just a basic concept at least, so which we have been discussed and so on. Okay, so anything you want to ask, you can give it in the chat. So I'll try to check the chat in between and we can able to have some discussions as well. Okay, right. So shall we start with this? Okay, so we are into practical now. So let me give it the analysis. Okay. So relatively, we'll be having the libraries. We'll try to import it first. Okay. So for any libraries, it might be the matplotlib of MathWorks, or it might be Seaborn. So we need to import those libraries specially. So I'll try to import it. So we used to have the common keywords. So import. Let me have this pandas first. So I'll try to mention these all the multiple libraries as it is. Okay, so matplotlib. So we can say like an mat. It's like an mathworks. Okay, so matplotlib dot python plotting, as of course like short names we used to take it, right? So we'll try to use those things. And Seaborn also I'm trying to use it now itself. So SNS, you can give any short names and so on. Okay, so we'll try to use it out as it is. Fine. So these are commonly for any particular data analysis when you're trying to use it with Python. So these are more relevant. You can able to say much used one. You can able to specify it out also. Of course, not only in data analysis, even for your data science perspective also, these libraries again you'll be using it out as a continuation part of it, because there is a life cycle. Maybe you might have been heard of the data science life cycle, right? So it will be a full view from your business understanding till your end view of your deployment. Okay, so where your outcome which you have been received, so till there all these libraries will be the a kind of package itself. Okay, so it'll be much used one, you can able to say. Okay, so beyond that will not be having any other stuff much greater than that. Can able to specify it out. What no libraries you are learning that has some advantage. I mean, kind of basic till the advanced you, and even they have the versions will be keep on adding new things to it. So this will be keep on growing. So that's not an end to it. So we'll be using this as such. Okay, so fine. So let me go into a data wise. So I'll try to show you one data set, and I'll try to specify so what and all it has been. I mean, what and all fields have been available, and respect to what kind of data set it is, and so on. Okay, so let me first load that data so we can able to see it, and let us give it as a kind of variable names, right? So we used to give some variable names. So pandas dot. It's a let me check. It's an Excel sheet only. So let me check it once. It's an Excel sheet wise. Okay, so let me have the datas. Okay, yeah, it's an Excel sheet, and I'm just checking into my document sessions. Okay, so Excel, and we used to give the file name, right? So we used to mention the file name and Excel file it is, and so on. If you are specific to your relevant to the path location and so on, so you can able to use the R as relative location or relative path location, you can able to say. Okay, so it depends on that. So let me execute and check. So data has been loaded. Okay, so data has been loaded here, and we can able to try it out. Yeah, so okay, just a second. Yeah, you can also try it out. So let me give this. Okay, so I'm able to share it. Okay, so meantime, you can just go to into the documentation and so on. Okay, so if you want to view the data and so on, so it will be loaded into the document. So at that time, you can able to list out also. Okay, so but just listen here relatively. You can see your data and so on. Okay, meantime. Okay, right. So here you can check it out. Um, dot head is nothing but your you can say like the first five distribute, right? If you just give it as a data variable name, it will distinct out the whole data set itself, right? So in that view, this data, it's nothing but one of the um, a kind of rice production kind of company. Okay, so relatively, it's almost a very large company base. They have it out, and mainly for their yield and quality of the rice. Okay, so they used to check it out specially. Okay, so they have a data like yearly wise. They used to produce an yield, and based on the location where they want to yield and plant that particular crops and so on. I mean the rice crop especially, and what kind of hybrid. It might be two category wise. So hybrid wise, they would check it out. And the basis, if I try to plant in this particular week, and for this particular hybrid, hybrid is nothing but a kind of method. Okay, so for the rice production wise, the method they are trying to use it. Okay, so hybrid, they especially they are trying to use it two different methods. So in one method, in this particular location, in this particular year, and planting in a particular week, so how much yield and the quality it would be. Right. So in a simple way of understanding. Right. So we can able to list out in that specific way. So we'll try to check, and no need to worry about the data. Okay. So we'll be receiving the data, not to worry about it. So meantime, just understand here. So we can able to check and so on. Okay. So no need to worry about that. So the meaning is like, so we have the data. So we'll be receiving the data. No need to worry about that, everyone. Fine. So this data set is a rice production data set, and relatively in a particular week and specific location, and which kind of hybrid method they have been producing the rice, how much yield and the quality it would be. So it's a kind of almost, I think it has 4 years of data, and based on the location where it has been um, located and so on, and planting wise when you're trying to apply it out. Okay, so this is the high level view of the particular data set. Okay, so with this data, how we can able to visualize. Okay, so it might have a lengthy visualization also. We can able to alter, we can able to modify many kind of in between stuff. We can able to check any uh, relatively any missing information have been present and so on. We can able to standardize the data. So many things will be coming by and passing by. Okay, so we'll try to apply in normal method how we can able to use it out. Okay, so I'll try to uh, show it out how we can able to display it. So normally for a particular data, if you see here, if I give dot info, so if you have been known, so this dot info is nothing but a kind of specifying the information about it. Is it a null values, or I mean null values is nothing but any missing information have been present, what kind of data type it is it an integer, is it a float, is it how many number of columns, I mean how many number of fields have been available. So we can able to see a full view of understanding. Okay, so this info functionality will be much relevant also, so we can able to check it out here. So now you can see you have a year column, location, hybrid, planting week, yield, and quality, right? So multiple columns which already have been mentioned about. We have that data here, and almost 976 records have been present, right? And some of them have been integers, I mean integer column, and some have been like float. Okay, so this yield and quality is like in float columns. Okay, so respectively. If you have been observed, so here you can see like quality column contains 972. So the meaning is like there is some missing information present. There are some missing values, almost like four missing values have been present in that particular quality column. Okay, so this is just a kind of understanding so that data has some missed information. Okay, so even alternative we can able to check it out. So let's say like we have another function also dot is null dot sum. So it will be directly displaying that which column has the missing information. So here you can see that. So the quality column has four missing values, right? So some all the historical information not be displaying there, right? So some will be missed also, right? So it depends. So that we can able to identify using this info using these functionalities. So data.info and data.easnull.sum. So this is a kind of one of the step, actually one of the step you can able to say. So data cleaning process or data mining process, which comes under the life cycle. Okay, so this all will be required. How we can able to identify there is some missing information into our a particular data set or into a particular data which we receive from the client and so on. Okay, so we can able to analyze, and what kind of data type it is also we need to find out, because we need to check, because here sometimes it might be displaying as a string also. Okay, so it depends on that. It might be displaying as a string view, and the location, hybrid, planting week, anything, any different columns it or it fields which have been present, need to check it out whether it's a kind of any relevant kind of data type it is or not. Okay, so this almost like what are all fields we have been seeing is a relevant kind of data field only. Okay, so data types which have been present, nothing like string, it's not there. String mostly like other than text, so we can able to check and we can able to modify that also. Fine. So now if you want to um or you can select, and if you want to remove that particular missing information, we can able to drop that particular missing rows, we can able to drop it out also. So we'll drop it out, and then we'll have a full data view. So I'll try to specify it. So some have been maybe some have been loaded, some have been trying to come along with me parallelly. So you can just check it out here. I just loaded the data, loaded the libraries, and then info we had it out, and then we have been applied the dot eastern and dot sum. So further we'll be having the charts, and we'll try to apply and check it out also. Okay, so relevantly to this data set. Fine. So now I'll try to do a kind of dropping the data for now, because very less you can select very less kind of um, rows which have been missing. Okay, so only four rows. Okay, but normally in a real-time view, so if there is even a few number of missed information, so we can able to gather from the client itself. Okay, so we can able to have some discussion, and we can able to identify, and if they have that information, we can able to gather it, and we can able to apply back into our data itself, because we should not miss some information. We need to have all the relevant information back to our full historical data and so on, right? So we need to have that. But here for now, so if you want to handle the data, we can able to handle that. As in we used to say like imputation methods. Okay, so either like a pre-forwarding or pre-backwarding and so on, or even relevant to the similarity wise. So in that particular week, in that particular year, in that particular location, same kind of yield and quality have been present. So we can able to match and we can able to make it. Okay, so that kind of methods, imputation methods, we can able to do it, or even finding the average relative to it. So these are all multiple ways, a kind of assumption only. Okay, right? So it's a kind of assumption way we can able to apply and we can able to check it out. Okay, so these are methods we can able to go forward. For now, I'm trying to handle this data like removing those missing information, and then we can able to take it forward here. So now if we check dot is null dot sum, so what happens? So those null values have been removed. So we have been ignored that null values, right? So we have been removed that as it is. So now we have been removed it here. Fine. So let's try to do one thing. So we'll try to um, apply kind of multiple charts which have been present, right? So we can able to try with a kind of scatter plot. You can able to try it out and comparing with, let's say we have the planting week and planting yield, right? So we can able to make some kind of scatter plot. So we'll try to relatively you can able to plot and you can able to analyze to understand that so this many have been more, and for this particular location or this particular week more number of fields have been high. So we can able to visualize that way, and we'll see that so how we can able to apply it out also. Okay, so now let's see here. uh, Let me apply it out for this. Okay, hope everyone have been till now have been applied and check your data and so on, right? So let me use the matplotlib itself. Okay, so PLT is your short form. Okay, so like kind of nickname you can able to use it. So scatter plot you can able to use it, and your data, this data is your kind of parameter we can able to say. So data and your variable name also is data only, and like x-axis and y-axis would be required. So we can able to mention the corresponding field name. So planting week. Okay, so that is one of the column you can able to say, and your y-axis, let's say we'll try to go with the yield. Okay, and this is the location wise if you want to highlight. Okay, like color wise if you want to highlight also you can able to highlight. So we'll try to make in a different view. Okay, so we'll try to see in that format, and you can able to check how much relevantly it is trying to display. Okay, so we'll try check in that format. So for now, hue I'll try to get. Hue is nothing but a kind of category column. This location is one of the category column. Color wise differentiation will be applying it out. Okay, so to differentiate that color wise and so on. And if you execute this one, automatically it will be displaying, but a little bit of other functionalities will try to give it. Okay, so to look and feel and so on. Okay, so we'll try to make it in relevant way. So planting week, we are trying to compare with the yield, right? Yield. Okay, so we'll try to compare it here. So yield wise and planting week, and plt dot show. So let's say execute has no scatter plot. Okay, sorry. Actually, scatter will be there. So I think I have been taken with matplot. Okay, so I think Seaborn will be much relevant now. Yeah, fine. Okay, so for matplotlib, if you're trying to use it, so relevantly plt.scatter would be present. If you're trying to use it with the Seaborn, so SNS have been taken scatter plot, so that's functionality. So I've been taken with matplotlib. Actually, with Seaborn we can able to use it out. So this is like a kind of scattering kind of plot between the planting week and the yield wise we have been applied out here. So this is like a look and feel wise, it's like very small and so on. We'll try to increase the size also. Okay, so a little bit size, and then later on we'll try to see the differentiation, what is the meaning behind it, and from that representation what we are trying to get it. Okay, so we'll try to apply and see. So let me increase the size. So figure size actually we used to say. So we'll try to give some size, like in high width and height we are trying to add it out. Okay, so nothing more than that. And if you want to give some palettes, so color wise differentiation and so on, so palette we can able to use it. So palette, and some name we can able to give. So viridis, plasma viridis. So on multiple names you can able to align it to. Okay, so fine. Right, so now what we have done is like I want to compare with the planting week and the yield. So normally just think in the meaning, just think in simple understanding wise. Okay, So in a particular week, okay, so in a particular week, my crops has been planted in a location wise. Now color wise have been differentiated, right? So in that particular location and each and every week, so your yield will be growing. Okay, so in that particular location wise, yield will be growing also. So if you see the color differentiation, so location has one, two, three, till six locations have been present. I mean, location is nothing but your places. So in a six locations and each and every week, so you can select from 1 to 14 till 16 it has been present actually. So we are showing till 14 only. More number of, you can say like an at the 8th week. Okay, so you can select more number of at 8th week. So at the location 1, so yield has been morely present for the location 1 basis. So these are nothing but your yield values. If you just scroll above, so here you can see, so 52 point, 49 point, 63 point, and all these are yield values you can able to see. Based on that yield, how much quality of the rice would be. So that is the logic we have taught. Okay, so yield wise, so those each and every location basis and respective to the planting week, so yield wise, so how much it is and so on. So these are nothing but your each and every value. Okay, so they are not nothing but like not the sum or average and so on. Those are the values which have been present. Some yields might be very less value, might be even 20, 10, and so on. Okay, yield values, and some will be high. So we can able to check. So right, so you can able to check based on the location wise. I can select the location one which we have been planted at the 8th week, more number of yields which have been used. Similarly for the location wise, let's say 3 or 4 and so on, you can change the colors respective to that. So 3 and 4 and so on, so mostly at the location to 2 to 6. Okay, so I mean planting week is been between the 2 to 6, so location wise for third and fourth and so on. Right, so we can able to differentiate. Okay, so this is just a starting kind of analysis. Okay, so we can use any other, we can say like any other fields also to apply and check it out. So not only for scatter, even for a kind of bar plots and even with pie charts to differentiate the percentage wise for the how much hybrid percentage for hybrid one and hybrid two. So we can able to differentiate in that format also. Okay, so we can able to use in that way. Okay, so now this is just an understanding for now how we have been applying that way. Okay, so we had to, okay, let me give you again a kind of understanding view. Planting week we had it, yield we had it. Mostly the scatter will be using it as an mostly wise with one of the continuous values you can able to use it and along with the category column. Category column is nothing but limited values or sometimes even with both continuous, but mostly one category column and one continuous values column, this scatter plot will be much relevant. So now we are trying to compare with like planting week, location, and the yield. Okay, so when you come back to your visualization view, so we had the planting week at the x-axis. So like from 1 till 16, the number of weeks that have been present out and relatively the yield in the y-axis. So yield will be from low to high and so on, and your location basis. So in which particular location it has been planted and in which week it has been planted. So especially the colors wise, it is being trying to get differentiated. So by seeing that, that is a kind of idea we are trying to get it like the location of one, the planting week which they have been used. So eighth week. So more number of yields have been coming by for the location of one which has been planted. Okay, and similarly with the location of 2 to 6, more number of which have been planted, the crops which have been planted. So the location of 3, 4, and 5 have been more planted in the week of 2 to 6. And from 8 to 8, 9, 10th week and so on, which have been plotted respect to the location of 1. Okay, so location base of 1. Maybe let's say one area. Okay, so let's say one area has been present. If you okay, we'll try to divide as an India wise. So let's say this 8, 9, and above 8 you can able to say. So that is being placed in North India. So the meaning is like in North India, so location of North India. So planting week at the 8th week, they have been planted in the North India itself. and from 2 to 6 they have been planted in the South India. In that meaning we can able to align. So just for understanding I'm trying to mention. Okay, but this is data set relatively like a meaning of locations of 1 to 6 and specific to the hybrid. I mean normally data when you're trying to see. So hybrid, and they have been planted the crops, and respect to that how much yield and quality it be. So respect to that, now I can able to say in this location wise, for location of 1 they have been planted around 8th week, beyond 8 weeks, and I mean because there has been more, and from 2 to 6 they have been planted for the location of the 3, 4 and 5 and 6 and so on. So that we can able to segregate, or we can able to make it in depth streaming wise and so on. Okay, so that is further on we'll try to add it out, and you can able to try it out yourself also. But this is just a starting stage. So with one particular voice we have been applied out. So I think hope everyone able to get an understanding. Yeah, location and yields and so on. Fine. So let me try it out with the two categorical column, right? So we can able to apply with bar plot also. So let's say I want to check hybrid voice. Okay, so hybrid is one of the column we have it out. So if I try to give it as here data dot columns, so hybrid is one of the column. Hybrid is nothing but um, the method of cropping the rice. Okay, so hybrid is one of the way, like two different methods they have been trying to crop it. So in one way of method, the rice would be good. In another way of method, rice might be a little bit, compared to first one, it might be a little bit less or it might be high. So good quality wise and so on. So this hybrid, you can able to check like how much account of whether hybrid one or hybrid two. So currently they have two hybrids. So one or two, how many is being more in this particular data? So we can able to check it out also. And later on, we can able to can select, and we can able to plot that particular in a pie charts also, and you can able to check it out. Okay, so I'll show the both the ways. So with bar representation of count and as well as with the percentage wise, so we can able to differentiate that. So let's check it out here. So okay, sorry. Okay, so here cbond dot count plot. Okay, so I just want to see which hybrid has been more. So hybrid one, more data has been present and so on, or that meaning wise you can able to take it. Okay, or hybrid 2 has been more and so on. So but I don't know, but I want to represent and I want to see. If you want to see just the values, you can able to check it out also. Okay, if I give it as an value count, so it will be displaying that value and so on. I show that also. So but as a presentation wise, you can able to analyze it here. Okay, so let's apply and check. Yes, so okay, so data equal to, okay, so let me give some color differentiation. So here you can see that the meaning of hybrid 1 and hybrid 2. Okay, so two different ways. Okay, so hybrids which have been present. So now can see like hybrid 2 is been more. I mean more number of data wise when you try to see. So hybrid 2 wise, method wise, I mean let's say like method 1 and method 2. Okay, so in that wise method 2 has been more they have been trying to plot it out and so on. I mean in the crop wise. Okay, so in the rice crop wise they have been plotted and so on. You can able to say for the hybrid 2 compared to hybrid 1. Okay, so this we can able to take it out with the data, and we can able to see it as just a kind of bar plot. Okay, so we used to say with the point of view like bar plot you can able to say. So this is like bar representation mainly for category columns only we'll be trying to do it, not for continuous values and so on, mainly for the category column. Okay, so there are few representation. Okay, so some you can say like continuous values will be applied for scatter, and bar plot you cannot able to go with the continuous values, right? So almost you can able to represent in that way also, because there are specific way. If I apply a yield and giving it as a bar plot, what happens? It is not a relevant one, right? Or if I give it as a quality and then apply for the bar plot, what happens? It will be giving in a lengthy way. Each and every value it will be giving in a bar. I'll show you. I'll show you what happens. So respect to the category columns only, we'll be applying and check it out. Okay, so if you want to see, I will show you here. There will be some meaningful information. It's loading, but actually for yield, you should not be able to. I mean, I can say like in for continuous values, you should not go for the count plot. I mean, those bar plots and category column wise and so on. So always category kind of columns will be representing only for the bar plots or pie charts, you can able to say. So you see here, this is not a good representation. Okay, so when you try and see, because I have been used with the continuous value, yield is a continuous value. I mean, yield is a continuous column value, it not be having good representation. So this is not being used in our plotting. So continuous value fields are not allowed. Okay, so always you should go for the category column for the bar plotting or count plotting and so on. This is a bar representation, right? So bar plotting you can able to say. So continuous values will be used out here. Okay, so fine. I hope everyone have been able to get it right. So anything required, you can just Excel sheets. I mean, data you can able to check it out. Already has been shared. Just check in the chat. You'll be able to download the data set also. Okay, fine. So we have tried with scatter. So one meaningful representation of planting that week, location wise, and we have been comparing with the yield, right? So and we have seen like more between the 8th week and so on. More the location of one has been planted and so on. And similarly for location of 2 to 6 and so on. So location wise of 3, 4, 5, 6 have been planted more. And similarly for the hybrid wise to differentiate that. So hybrid 1 is less and hybrid 2 has been more. I mean like method 1 has been less, method 2 has been when they applying that crop yielding and so on has been more also. We can able to differentiate that. Fine. So just a second. Let me we can able to do the uh, to plotting also. So let me try it out. Um, okay, so the same concept. Okay, so the same concept. So now what I have done is like okay. So here some have been asking like location wise why 3 has been repeating. So it's not like 3 is not been like kind of repeating. It's like the values which have been present. Okay, so in that particular location, so the planting week wise, the yields, multiple yield values will be present, right? So it's not like only once they'll be planting and in that particular location, so on. So for the multiple years, okay, so there are 4 years, okay, so in this data, so they have been planting, so relatively in that particular location for each and every year, and it might be multiple hybrid wise also. Two hybrids we had out, right? So according to that, fine. So now here, if you see the count plot when you're trying to check it out, okay. So I've added one or more category column. Okay, so location I added one more category column. You can give location or even you can try with year also. Just replace with this location, and if you give it out year also, it will be differentiating with 4 years. So now if you see here the hybrid one, okay, so respect to the count. Actually, everything will be like count wise only be trying to do it. So from this one, I can able to say like the location of 4. Okay, so location of 4 for both the hybrids, more number of data has been present. Okay, so I can able to mention that way. So location of 4 and the hybrid 1 and hybrid 2. So more number of data has been present here. So meaning like in that particular area, more planting or more cropping is being done. So in that way, you can able to differentiate also, right? So the meaning is like in a specific location, less cropping is being done, or in a specific location, more cropping is being done. Okay, so you can able to differentiate in that way. So meaning is like again, it's like little bit in depth. Okay, so if it is being specifying that the fourth location more planting is being done means there is some useful outcome from that location, right? So if I plant a particular crop yield in that particular location, so my outcome will be high, right? So that is the meaning you can able to come into, right? So that is a specifying. So from this data I can select fourth location, more number of more number of planting is being done, and relatively for both the hybrids. Okay, so hybrid one, the method one, method two, you can able to say. There's also one more. If I give it as, let's say, let us try it out at year wise also. Okay, so which particular year more, you can say like in more relevant um, planting has been done for the hybrid wise, you can able to check it out. So here you can see like year two. Okay, so you can see specifically year two is been more. Okay, so in the year one, with using the hybrid one or method one, in the year one is been less, and year method two is been high. The hybrid two is been high. Similarly, both the years having high things like in high usage of it. Okay, so high planting or high planting or plotting, you can able to say with the crops, they have been done more. So in the year of two. Similarly, the year of four, if you see, it has been less. Year of four, hybrid two has been less, and hybrid one has been high. The method of one and two differentiation. So this how we are trying to analyze. So now I can say like at least for these two, I can say like specific to the hybrid one and hybrid two. The year one, hybrid one is not been much done, and hybrid two more usage is been taken. Method one and method two, right? In that meaning. And location wise, if you try to specify it, you can able to differentiate that fourth location. So location of four, more data has been used for both the hybrids. Okay, so in that meaningful insight, you can able to say. Then relevantly, you can able to think like if more number of fourth location wise it is being used means then how much the yield and the quality also should be high. Okay, so quality and yield should be high. It might be high, it might be less, but we don't know. But later on, we'll be trying to see it out also. So these are the insights. Actually, these are the insights we can able to gather because just in a simple way. So I've been gathering some information now. So I can say like in this particular year, in this particular location, the yield and quality might be high. Okay, so based on that planting and based on the respect to the plotting wise when they try and do it out and so on. Okay, so from the data we are trying to gather that particular insights directly. Okay, so respect to that only. Fine. So I hope you're getting some points. If you want relevantly, you can able to try it out with other corresponding category columns also can able to try it out also. Okay, so fine. So this is how we used to do it. Okay, so this is how we can able to analyze each and every one by one for each and every particular data. This is how we can able to analyze. Okay, so even for similar other charts also, so we'll be trying it out with the pie chart. So we'll try it out. So respect to that, so I'll show you. So here, let's try it out here. So let's try it out with the pie chart directly. Okay, so let me put it out here. Yes, loading here. So what I'll do it is like PLT.py. Okay. Before that, we will try to give some labels. Okay, we need to give some labeling. We will try to give it. So I'll check it out with the hybrid. hybrid. Already we have known about the hybrid 1 is less and hybrid 2 is been high. So already we have been known. And value counts is nothing but how many number of values have been present. So I'll take that as an index and we'll give some sizes. Okay, so we need to have some sizes. So what I'll do with that hybrid, same value counts and we get that values back. Okay, so value counts, we'll try to pass it out here. Value counts dot values. Okay, so now these labels and sizes will be adding into our pie chart. Okay, so those sizes and nothing but your labels. Labels are nothing but those values which have been representing and so on. Okay, so we are trying to add it out here. And normally if you see pie charts will be like a kind of percentage, right? So respect to the percentage wise, we need to give it out also. Okay, so there is some a kind of auto percentage kind of parameter we can able to use it out also. So we say it as an auto percentage PCT, and we need to give it as a percentage values. Okay, so this I'll try to specify what is this 1.1 F and so on. Okay, so I'll try to change, I'll show it out also. Nothing but like it's like overall around percentage wise. Okay, so with one decimal we will be trying to display it out also. We can able to modify that. Okay, so now let me execute and check. Okay, fine. So we got some representation now. So relatively, you can see that with count plot already we have been seeing that hybrid 2 was been more, right? Hybrid 2 has been more and hybrid 1 has been less. So similarly, the percentage wise also can able to check hybrid 1 with 38.9 percentage, almost like for 39 percentage wise. Similarly to hybrid 2 was like 61.1 percentage, because the data has been relatively more in the hybrid 2. Already have been mentioned about that. So from the count plot itself, we have been seeing, but with the percentage wise, if I want to see, so relatively hybrid 2 is been more as a percentage wise also. We can able to check in that differentiation. And if specifically to the auto percentage, so if we just check it here, it's almost like similar to that. So if I give it as 2.1 is nothing but like round off and so on. And I mean 0 to 1 we can able to give it out. So point is nothing but your decimals, how many decimal, 2 decimal, 3 decimal and so on. If you see here 0.3, if I give it out, 3 decimal values will be displaying in the percentage. So that is the difference. And f is nothing but normally we see it as a float. Okay, so kind of float values you are trying to get in a percentage and so on. Okay, so you can able to mention that format. If I give it as 1.0, it will be given as an a round off without the decimal. It will be trying to give it out here. So this is just a kind of simple changing with the values and so on. Okay, so but main representation with the pie chart. Okay, so we can able to identify that respect to the hybrid. So hybrid 2 has been more as a percentage wise. So you can able to display it out as well. Okay, so that is just a meaning wise you can able to come into. So this everything is like kind of analysis, right? So which when you're trying to mention it out and so on, so comes under the analysis specifically, right? So hope I am being clear with this one. So any doubts you can just mention the chat also. Okay, so one by one. Hope others also have been trying it out in your Jupyter notebooks. Right, so this will be a little bit interesting. Okay, so um, maybe like when you're trying to, this is actually a real time one, right? So this will be much interesting. So you're knowing about the a kind of rice production which they have been doing it out, and crop yielding in a particular planting wise, which particular can say like in which particular week when they plant or when they crop, so I'll be getting more yield and so on. So it's like you're getting some good respective insights. Okay, so there is a meaning representation we can able to give it out. And beyond that, even we can able to identify these frequency wise also, in which yield is being more high and which yield is being more less and so on. I mean, a kind of normal distribution wise, you can able to check it out also. So many have been heard like how we can able to distribute the data for continuous values. So like, is it normal distribution, or is it like kind of skewness has been there and so on. So histogram will be a representation chart for that. Okay, so specifically histograms used to mention it out at that time. Okay, so relatively you can able to use it out. So we'll add that one also here. So specifically histogram. So we'll try it out. So I'll apply and show it out also. So we got, let me give it out here below. So I'm just trying to you want histogram plotting. Okay, so mainly for continuous values, we'll be using that histogram. Nothing but how the data has been distributed, specifically for continuous values like yield and quality. Okay, so in that way we can able to differentiate that. So let me check. Hope I'm being audible now. Is it being clear? Just give it in the chat if yes or no. So if there is any disturbance, just mention the chat. Okay, so I'll try to adjust with that. Okay. Yeah, thanks, Amar. Fine. So let's um, give it as histogram, right? So from Matplotlib itself, we can able to give it out. Matplotlib um, histogram we have been given. Okay, so histogram and now data of year. Okay, so um, okay, I'll try to take it only with the yield. Okay, for now, data of yield, I'll try to use it, and I think this will be fine. So let me plot and check it out. So okay, first let me execute and check. Okay, so now can check this. So this is just a starting basic representation of histogram. Okay, you can able to give the lines, and then we can able to represent that look and feel wise also. So for yield I've been given, and let me give it as in this meaning. Bins will try to give it some 10, will try to give it. Bins is nothing but that range we are trying to give it out, right? From 0 to 10 and so on. So that we can able to adjust. So how many bins in that particular interval we can able to adjust out also. Okay, so there is a meaning behind it. And let's say edge color. Edge color, we'll try to give it as commonly we used to go with black only. Okay, so that will be looking good. Okay, so edge color. So that bins which we have been segregating, right? If you're giving it as here. So here you can see the bins has been 5. So meaning is like I want only that 5 kind of bars. Okay, so that interval range. Out of this 0 to yield might be till 100 and so on. I mean even beyond 100. Out of this I want to segregate into 5 bins only. So it will be dividing it. It will be dividing in that range. So if I give it as 10, so from 0 to, I mean, yield of minimum to maximum and so on. So only 10 kind of intervals will be getting it out here. So that we are trying to represent. If you want to increase that bins, you can able to increase. That's not specifically and so on. Fine. So now you can see this histogram. So it's a kind of frequency count. Okay, so meaning is like frequency count here. So I can say like for this particular yield, more range of yield have been between the range of from 10 to 30 and so on. So do you agree with that? So more number of data of the yields have been between the range of 10 to 30, and less number of yields. You can say like an high yields like frequency count which has been less. So high yields have been more less preference in the respect to the high range wise and so on. So between 10 to 30 or between 10 to 40, more number of yields have been present in the data here. As the yield has been increasing, the frequency count has been decreasing it out. So if anyone can able to specify what kind of distribution it is, if we have been known. Okay, so what kind of distribution when you're trying to look into this histogram, can you able to specify it out? Just mention in the chat. So let's give you time. So what kind of distribution by looking into the histogram? Is it like normal distribution or is it like left skewed or is it like right skewed? Anything? Can you able to specify it out? Right. Okay. So many of them mentioning it as some are being left skewed, some are being right skewed, and so on. Okay. So, but this one is the right skewed one. Okay. So this which you are trying to see, we say it as a right skewed. So normally, right skewed is nothing but where your right hand side part, your lengthy tail, so the number of frequency in the right hand side, high end of right hand side is been less, so it will be like a lengthy voice. Okay, and left hand side, I mean kind of left hand side is been high, but right hand side will be down. So left skewed, it's not been specified, it's a right skewed one. Left skewed is like correspondingly the left hand side where we have your frequency will be less. Okay, so and the right hand side frequency will be high. So like more number of values in the high end will be high. So that will be left skewed, but this one is a right skewed one. So right hand side the frequency has been less. So like kind of outliers which have been mentioned out further on, if you try to expand that winter view so on, so right hand side will be a kind of skewed. Okay, so this is the right skewed one we can able to mention it out here. Even you can able to add the you can say like kind of KD plot, you can able to specify it out also. So displaying the you can say like the curve wise. Okay, so distribution wise when you're trying to specify it out also, so you can able to display that. So let me add that one. Normally KD plot or distribution plot at the time you can able to display that one easily. Okay, so let me apply that one here. Can give it in this way. Let's say Seaborn dot displot or histogram plot, you can able to give it out. Data of yield. Okay, data of yield. And normally we see it as a KD equal to true. Let me check, is it displaying or not? Yeah, so now you can see here. So same thing, it's the same histogram representation, but another kind of functionality, distribution plot you can able to see. So we are using that distribution plot here. Okay, so representation wise and you're trying to apply it out. Same the data of yield, that column, and KDE kernel distribution estimator. Okay, so or kernel density estimator you can able to see. So this is a normally it's like in probability distribution wise, and a kind of curve we can able to display. Nothing but your where we have high frequency, so it will be the density will be high. Where the frequency has been less, the density will become as less. Okay, so disk plot is nothing but distribution plot we can able to mention it out here. Okay, so this is the distribution plot. Okay, so that functionality name distribution plot. Okay, so this is another functionality which we can able to use out also to represent this kind of density wise to represent here. Okay, so this also we can able to work on. And later on like color wise and this styling wise and so on, that has the parameters that we can able to apply it out later. But a kind of representation which we can able to align it to. Okay, so this has been much used. Even like yeah, so relatively Um, this KD is nothing but your kernel density estimator. Okay, so kernel density estimator. Okay, so KD is to mention. So nothing but this curve. If I remove that, if I give it as false, okay, so you can just check it out here. You can see just only that histogram will be representing here. So previous what we have been seeing, the same histogram with all the bins. Okay, so without that curve, it will be trying to specify it out. Only the histogram will be displaying. If I give it as a true, so the kernel density estimator, that curve where high frequency, more frequency has been present, nothing but the corresponding interval or the bars which having the count high has been high, right? So frequency has been high. So the respect to that, the probability is meaning is like there we have more number of yields have been present. That is the meaning of it. So if I activate, so true is nothing but you are trying to activate that curve to display. So now you can see, so at the frequency of 10 to 30 and so on, right? So at that particular interval, more number of probability is being high, the density is trying to get represented there. Got it? So similarly, if you try it out for quality, also the same thing. So same format, because that is also you can say like a continuous values, right? So quality column also you can able to try it out. So that also represents in this way. Mostly this histogram distribution plot. Previously we had a word called as hist plot itself, hist plot, and that also maybe it might be deprecated. And again, it's been displaying here. This plot also deprecated, and we can able to align it out in that particular range itself. And here you can see some difference between that two. If you see here, um, for KD equal to true when you're trying to give it, and KD equal to false. Okay, so you can see some difference here. So in the y-axis especially, so you can see the values which have been representing. So nothing but those are the probability values. Okay, so those are nothing but the probability density values only. If I change here, if I change that KD, okay, let me give it below. If I change here, if I give it as KD equal to false, I mean your density is being false. Only that histogram is representing, right? So normal frequency values like previous of those yield which are getting those frequency values, right? So that has been displaying. But if that density is being displaying along with that, your curve when you're trying to represent, so we'll be having your probability density values here. So these are probability density is nothing but your based on your frequency and the interval, based on the frequency and the interval. So it will be calculated. Okay, so just a normal division calculation only. So interval and the respect to that frequency count. Okay, so interval and the frequency count is nothing but your how many number of yields have been present. So it will be calculating between them. So you'll be getting your density value here. Okay, so no need to worry about that. But representation wise, already we have been mentioning about 0 to 30 or beyond that. 0 to 60 is nothing but you'll be having little bit of values, but 0 to 30 is like more number of high frequency have been present and high density will be present and high probability that more will be yield will be happening between this range. So that is the meaning behind it. So but calculation wise, here in this one, it depends with the respect to the intervals what you're trying to use it, and your number of frequency which has been present from the yield data will be calculated. Just a division calculation, each and every respect to the density values will be arising it here. So that's just a simple view. Okay, so I hope you understand this one. So this is also one more histogram plotting. Okay, so histogram plotting and distribution plotting, we can able to specify it out. Okay, so hope you understood till here. Any doubts you can just mention it out. Yeah, so some might be even you will be asking like kind of univariant and bivariant, right? So others also might be doing that. So univariant is nothing but only one particular field. Okay, so one particular field we are trying to use it out. Okay, so univariant. So like comparing, let's say we tried with the yield, right? So that is a univariant kind of analysis we used to mention. If you see for previous bar plot, okay, so bar plot wise when you try to consider, so there was like a hue and even with the hybrid. So two things. So two things have been combined and you're trying to view it. So bivariant is to happens here. And even scatter. So of course it's a bivariant kind of analysis only. Univariant is nothing but only one particular field you're trying to use it, single. Okay, one particular field which you're trying to use it. That we mentioned as a kind of univariant analysis. And if it is like more than one, I mean like more than one is like two, three, and so on, multiple combined of fields, then it becomes as a bivariant analysis here. Because come two, three fields you're trying to combine and you're trying to analyze that information, right? So that comes under bivariant analysis here, right? So histogram which you have been plotted, that is a univariant analysis. Okay, so we mentioned as a univariant as a single a kind of field which you are trying to apply it out also. Okay, so this is one. And relatively histograms will be a frequency counts. Okay, so normally when you're trying to see how much high, how much low, and so on, so histograms will be represent to that. Fine. Now, okay. Okay. So other kind of plots, like even pap plots and all, if you say pap plots, now it's not been relevant actually. Pap plots and all is previously we used to have comparison for one particular each and every column, each and every column. So you can able to apply just a cbound or pat plot and so on. So but all the relevant with histogram or even scatter plot, so that will be present. But Paplot has been not been much required. So as per the current analysis and so on. But mostly this histogram, bar plot, pie plots, and specific to the data and so on. So that we can able to represent in a meaning of with these plots, especially. Okay, so we can able to use this specifically and so on. Correlation we can able to check. So we can able to use the heat maps. Okay, so normally if you try to apply, so if you say like cbound dot heat maps is to specify it out. So if we give it as data, that normally correlation depends on the specific data sets and so on. So category columns and all not be much required. Only for the two continuous columns, mostly two continuous columns is to give it out here. So okay, so for the heat maps and so on, when you try and apply it out. So here, if you see, it will be a combined view, but this is not a relevant kind of heat map. Okay, so only for yield and quality, if you try to see, that will be more relevant because other columns are category columns, right? So specifically, you can able to mention for the yield and the quality also. Okay, so in that way, it will be more a relevant feature and so on for to checking the correlation and so on. Okay, or if you want to check data.core, you can able to check your values of correlation. Okay, so correlation is nothing but your a kind of a relationship. Okay, so kind of how much strong they are. Okay, so you can able to say how much strong enough they have been between the yield and quality or between the plant week and yield and so on. But only for the continuous values will be using the correlation part. Okay, so but for the I can say like category columns, that will not be much relevant actually. Okay, so when you try to compare with the colors and so on. Okay, so when you're trying to apply and see it out, okay, so that will be a little bit different and so this is the difference. But understanding that correlation meaning is like more importance between the two variables. You can able to say how much more importance they are between the two variables. You can able to check it out in the correlation part. Okay, so that's a relevant part. Fine. So we'll be seeing about this. Okay, so heat map will be seeing at the last. Okay, so relevantly specific to that and so on. And here, if you see that yield and quality, so these are the two continuous values and so on. So when you try to compare it, so yield and quality, when you try and see 0.02, it's like very much very low correlated value between them. Okay, so here 0.02. So this we can able to check it out. And because here you can see yield and here the column has been quality wise. when you try to compare between them, the two values have been very much less, because there should be the range, right? So -1 to +1 is your correlation value. So there should be some range between them. So when you try to compare between and so on. So it depends on that view. So, but when you try to analyze it here, so it's like very less. So when you try to compare it here. So even further on for your ML modeling and so on. So these two columns will not be much relevant and so on. When you try to apply it out also relative to the accuracy wise and you try to check it out and so. Okay, so that differs. It depends on the data set which we can able to apply. So normally this correlation will be much required at that time. Okay, so you can able to analyze it out also. Fine. So fine, I want to add this one also, because of course we have been into the correlation. Um, Relatively, um, normalization and standardization also will be required. Okay, so we can say like yield is like having different meaning, and quality is like different meaning, or a scaling wise also you can able to say yield is a different scaling, quality is a different scaling, right? So both are totally different directions. So we can able to scale the data, we can able to try to convert. Okay, so between that range of -1 to 1 or 0 to 1 range, we can able to convert that scaling. We can say it as a normalization, or even like standardizations we can able to apply it out. So scale as we used to see. Now if you see your correlation was 0.02 between the range of -1 to 1, but if it is much closer to 0, no correlation, nothing, but there is no much importance between the yield and the quality. So there is no much importance here. So if it is much near to 1 or is much near to -1, there is some high importance between them, between the two variables. So respect to that, here we got like 0.02. So very much, very much, very low kind of values. I mean, it's like in quality and yield are very much low comparison or relationship between them and so on. So that's why I mentioned that. So it should be having high range and should be having like an corresponding to near to +1 or near to -1 and so on. So then only they'll be having the good kind of accuracy and so on, can able to relate it out also. Okay, so you can able to check. Right. So for standardizations and even checking out the outliers. Okay, so we can check the outliers also. Okay, so we can able to check using we have those relatively box plots, so we can able to try it out, and even z scores relatively and so on. Okay, so to check if there is any a kind of outliers have been present in the data and so on, so we can able to identify. Okay, so let's apply and check it out. So let's see that box plot, especially for outliers. Okay, so to check outliers. Okay, so to check the outliers especially. So any idea what is outliers? You can specify it out. What is the meaning of outliers? Let's see how many have been known about that outliers. Beyond the values. Okay, okay. Beyond the values. Anyone? Outliers out of ranges. Okay, out of ranges also good. Um, a specific meaning can able to mention out of ranges. Right. So okay, for example, age is 120. Age is 120 is, yeah, fine. So you can able to say normally um, outside the limits, right? So it's normally the age will be for now. If you say like from the limit of, let's say like from 0 to, and so I mean not like 0, like 10 to 60 and so on, common age more will be there and so on. 120 is like a little bit more, and it might be or might not be very less, right? So that is like an kind of outlier you can able to see, or even limits. Yeah, so especially like kind of upper limit and lower limit also, so you can able to specify it as an far away values also, or beyond the values. So that's right. So that you can able to mention it as an outliers. Because let's say according to this data. So yield and quality, if you try to check it out, so there will be some interval, right? So for the yield between this range and for this particular location and so on, and quality also between this interval. So some will be like every time will not be having good quality, high quality. So some will be like less quality also. So you can able to differentiate that as an kind of outliers. You can able to differentiate also. So some have been grouped in this way and so on, which have been more related to this range. Okay, so which have been more related to the one particular group and so on. So that we can able to identify, and which have been much far away, or it might be high or it might be low. We can able to identify it as an outliers, right? So exactly, so there is the limits we can able to mention it out, so that we can able to find it out through the box plots. Okay, so let's plot me with this. So Seaborn has the box plot actually. Okay, so we can able to use that box plot functionality, and let's say um, try to use it as location. I want to specify it as a location base, and yield wise, I'll try to give it out. So yield and the data which we are trying to use it. So let's see the outcome. Okay, so location wise, if you're trying to see, okay, so 1 to 6 already we have seen that locations, right? And previously, like the location of 4, more number of, location of 1 and 4 and so on. So we had more number of values and so, and even 5 and 6 respectively. So you can see here, like this kind of, you can see like some dots or like circles kind of thing, right? So those are relatively some kind of outliers, far away values you can able to specify it out also. Okay, so that we are mentioning between this range, some values have been a little bit far away and so on. So that we are trying to figure it out, so through this box plot. So why specifically we are checking out these outliers are nothing but at the time of relatively at the time of intervals. Okay, so at a point of modeling and so on, so to analyze and then this data modeling and so on, or especially for your predictions further part. So this will be relatively a point of assumption you can able to say. So because of this one high value also, one far away value also, your accuracy would be changing. Okay, so you can able to differentiate that accuracy would be changing it out also. But for analysis wise to check it out, for this location, this is the common range of, let's say, yield is been between the range of 0 to 60 or 0 to 80 and so on. I mean, between that range. But one or two values have been 100, 120, it might be a little bit high. But group of values that have been present is between this range of 0 to, 1 to 60 or 80 and so on. But one or two values far away. So the meaning is like more number of yield values will be between this one or two which have been high. Means there might be some kind of mislapping and so on due to this quality and the plotting wise due to some soil and so on. So it might be changed. Okay, it might be change depends on that scenarios. Okay, so it might be happening according to the data set I'm trying to mention. Okay, so right. So these are the kind of outliers to check. Okay, so but a kind of where um, we can able to remove those outliers also. Okay, so we can able to remove those outliers through we have libraries of SciPy. So SciPy in that stats functionality you can able to apply, and a kind of Z scores might have been known. So Z scores we can able to apply and then remove those outliers, kind of filtering those entries. Okay, so based on that view and so right. So respect to that. And if you enter into that, yeah, so yield can be predicted based on conditions. Yeah, exactly. So it depends on the soil, it depends on the moisture, because there are multiple data which will be coming by. Here is just only the few information of year, location, hybrid, planting week, and so on, right? But exactly that, Yield will be different on multiple sources. So rainfall, sunlight, exactly. So that is different. But relatively, for now, when I'm trying to mention, we are just comparing with the respect to the outlays. So just compare with the yield and the location wise. But normally a planting wise, when you try to consider, right? So planting will be more location, moisture, the rainfall, the sunlight, wind, and the soil. So many things comes across. So that is a little bit more data wise when I try to go in. Fine. So now respect to this here box plot. So location wise, so I can say like an from 1 to it's like an there are no outliers which have been present. All have been between the range specifically. But for 3, 4, 5, and 6, there are some little bit outrage of kind of values. I mean between that range beyond that limit. Okay, so beyond that limit, upper limit we are trying to mention. Lower limit, there is no any less values and so on. But beyond that upper limit, there are few outliers. I mean, like kind of faraway values have been available, have been present in this particular data, not available, present in this data, we can able to specify it out. So that we are trying to check it out here. Okay, even for quality also, you can able to specify it out the same way we can able to apply and we can able to relate. Okay, so you can able to mention it out here. Fine. So normally this box we used to, I mean, box plot is nothing but interquartile range. Might have been heard in statistics if you have been specifying. So that interquartile range will be specified out also. Quartiles we can able to specify. So right, so and even the that line which you have been getting inside the box. Okay, so that is your median value. Okay, so 50% of the median values. So 25 percentage, 50 percentage, 75 percentage, and 100 percentage. So 0 to 100. So that interquartile range will be present out here. So that is like a little bit in statistics wise when you try to enter into. So next upcoming will be learning further. So related to statistics, so we'll be having some workshops also. So at that time you can able to understand that statistics wise, this line would be representing for your 50 percentage of the value, your median value. Nothing but in the third location, your yield values will be there, right? So that will be marking that particular range. 50 percentage of the value, what it is. So and in the fourth location, what is the 50%? What is the 25 percentage? What is the 75 percentage? So on. So those are the values respectively. Okay, got it. Right. So right. So now let's try it out a little bit of interactive chart. Even Plotly, you can able to check it out also. So this is a simple Plotly voice. I'll try to apply it out here. Fourth location overall yield. So fourth location between the range we had it, but a little bit beyond upper limit. So there are few faraway values, right? So that will be specifically. So in that fourth location wise, we have it out. So that is different. Okay, fine. Fourth location for the yield. Okay, so total values is not 40. Okay, so it is, you can see that line. So upper limit, you can see it here. So it is beyond that 60, right? So beyond the range and so on. So normally the fourth location, the values would be beyond 80 also. So 80 something and so on. It depends on that scenario wise. Okay, so let me use this plotly. Okay, so this is like an interactive representation also. So we have on library. So plotly, maybe might have been heard of. So express as px. Okay, so let me use this library. Same kind of representation, but a kind of when you just scroll on that particular view, so you can able to check the values also. Okay, so let me specify it out. So just some variable name. Okay, so And okay, fine. So now here, so when you're trying to give it for this, so my plotly, I mean the express when you're trying to apply it out here, dot histogram as a functionality, we can able to use it. Your data has been available and your yield, we can able to, I mean a column we can able to give it out, and the bins, your interval that bins we have it out, right? So we can able to give that bins, and we can able display fake dot show. Okay, so let's see that. Okay, so let me execute. Oh, so it's running. So let me check. Okay, so this is, you might be thinking, so this is also similar kind of histogram, but what's the difference? So here if you see, it would able to display the values. Okay, so we check that yield, what is the interval and how much is the frequency. So that is displaying it out here. So Plotly has that preference. Okay, so a kind of interactive way of displaying. So kind of 3D voice also you can able to see. So we can able to scroll on that and you can see that the between 40 to 50, the frequency count of that yield is like 130 have been present, 130 records have been present here. So that's the differentiation. So, but in previous in Matplotlib and Seaborn, we don't have this interactive voice, but Plotly library has that interactions. Okay, so you can see that just I'm scrolling on that, you can see the count and so on, right? So this is one of the library you can able to try it out. So you need to install this, install the Plotly library, and then you can able to use it out for the histogram also. Similarly for a bar plot and even like scatter as a 3D voice also you can able to check. Okay, so if you want to see here, um, let me apply for scatter. So px dot scatter, it will be scatter 3D, scatter 3D, and we can give the data and your column. The column I'm trying to take it as yield, and the scatter contains two continuous values, right? So we can able to give your y column as quality I'm trying to give it, and representing with the 3D, so it's like z-axis we can able to give it out. So I'm trying to give one of the um, category column also. Okay, so and can give some color wise if you want to differentiate, you can give that color. So let me give it out the color equal to location. Okay, so that's just a some category column I'm trying to add it. Okay, so where you can able to add it out. So dot show. Let's see. I hope it will display. Yeah. So this is just a kind of 3D voice it is trying to display. Okay, so this is just interactive. Okay, so just for the interactive representation only, but concepts all everything will be the same. Okay. So when he's trying to see and so on, and even it will be displaying those, what is the yield value, what is the quality value, which particular planting week, and the location, which one it is. So it will be able to display it out just in a representation format and so on. So we can align in a different way, good looking one. So right, so I can check. Okay, more number of planting in this week of previously that week 8 we have been seeing, right? So week 8 and so on. So week 8, week 9, week 10. So more number of values of yield and quality between that range, so that we can able to check as a group. Similarly of week of 3, 4 and so on, below you can see, so those values below you can see that. So and the yield has been a little bit less and the quality is around 88 and so on, right? And you can see that planting week of 8, 9 and 10, so it has been a little bit, yield has been a little bit high and the quality is also has been high. So the group of that particular representation. Okay, so it's very much just like analyzing, right? So analyzing that view and so on. Okay, so we can easily we can display it out as much as possible and so on. Right, so fine. So just a few columns. We can able to apply, so it might be continuous column, might be a category column. So we need to specify x-axis, y-axis, and your which particular category column it is and so on. And color wise, just another category column we are trying to add it. But this one is a good little bit um, a viewable and analyzing, you can able to do it out also. Fine. All right. So and even for the box plot, even if you see um, previously some have been asked like that line between that box plot, what is the value and so on, right? Instead of going and again um, giving the functionality and then displaying it out so on, we can give it out here itself. Okay, so can you see that values also, that box plot, what is that 25 percentage, 50 percentage, 75 percentage, that I can able to see it out here itself. I can show it out here. Let me give it out that box plot, box and your data. Let's say that I had to give that location, because we have been checking about the location and yield, right? So y yield, the yield we are trying to give it out, and I think this will work. So let me to plot actually. So fig dot show. So here you can check points. I think some points equal to all. Okay, so um, previously what is nothing but is like above that only that outlays will be displaying. So if you see here, I'll just remove and execute. Previously only above that upper view, so though only the specifically outlays will be displaying. If I give that parameter as points equal to all, so the left hand side along with the box plot, so those grouped all each and every values will be displaying, and you can able to check that comparison also. So both the ways we can able to check. So now if you see here, previously I was mentioning about, so if you see that 50 percentage, I mean Q1, Q2, Q3, but I've been heard of these words in statistics. Okay, so Q1 is nothing but quartile one. So 25 percentage, median will be Q2. Okay, your 50 percentage of the values. And Q3 is nothing but 75 percentage. Upper fence is like above 75 percentage used to mention. And a maximum number of values and so on. Okay, so that we can able to easily check it out. Okay, so here is like interactive, right? So it will be easily checkable. You can able to check and you can able to see what is the minimum value, what is the maximum value, what is the middle value, we have it out and so on for all the box plots for your location wise. Okay, so easily you can able to check it out here. So that line which previously we have been asking, so that median value, so you can see that median value is now here. Median is nothing but 50 percentage of the value. Okay, Q2 we used to say Q2 or median. So interquartile range. Okay, so you can able to check it out here also. So this also through box plot. I mean in the what is this, a plotly wise, you can able to check and you can able to align it out also. Okay, so look and feel wise, it will be much easily, and those values will be easily you can able to check it out here itself instead of again um, viewing that values. I need to give that mean function, maximum function, and what is the quartile value and so on, so that we can able to check it out. Even another way like through a describe function also you can able to check. So describe a function might have been seen. So that is the summary statistics we used to see, right? So that also you can able to give it like data dot describe. That also displays the whole what to say, all this values in one shot you can be displaying it out. So that 50% median everything will be displaying here. So here you can see all this we can able to align it out. So your 50% is your respect to the year and the yield and the quality. Okay, so but this is for the overall data, not for the specific location. Overall data we are trying to get. Here it is splitting into location wise. Okay, so that is the difference we have it out. Okay, so this is also one more, but mostly box plot we can able to use it out. So that's, but this is the functionality through plotly. Okay, so dot box you can able to give it which data it is, which location, I mean your x-axis and your y-axis, and you can able to display it out here. Right. So these are mostly kind of library wise when you're trying to use it out and so on. Okay, so which have been mentioned out relatively. Right. So there are tools. Okay, so which we can able to say like auto visualization tools also which we can able to specify it out. So auto visualization means like it will be displaying everything. Okay, so it has that capability to display it out and so on. Let me show it out here. Some tools like SuiteViz and AutoViz, I mean auto visualization, suite visualizations. So those are relatively like auto exploratory data analysis they used to mention it out. So automatically everything will be displaying in one shot and so on. So that has that capabilities. So that I'll show it out, but relatively install and then we need to again use out and then we can represent those features in specifically. So I'll show it out here. Those we say it as an auto VDA. Okay, so multiple kind of I can say like multiple kind of tools. Okay, so here you can see detail, pandas profiling, and sweeties. Sweet visualization, actually we can able to say sweet visualization, auto vis, so auto visualization and so on. So this also we can able to use it all the visualization stuff in one shot, but relatively if you want to make our own customized kind of a view, so then we need to come back to our matplotlib and seaborn and so on, because sometimes auto visualization also some will not be displayed, some we need to customize and we need to create our own plotting, right? So at the time will to be relatively required. Okay, so this is, but you can able to try it out. So this I'll share it out the link. So relatively you can able to check and we can able to apply it out your auto visualization as well. So many things have been adding into, I mean kind of which we can able to say like libraries have been coming by and so on. So but as a starting wise, we can say it as an, but most repeatedly is like matplotlib and seaborn, and respect to that these are the libraries have been more relevant. Okay, so more useful one and so on. Okay, so that's what I can able to mention it out here. Fine. And beyond that, which are the tools which are relatively like cloud-based tools like Tableau, we have it out, Power BI, and many other tools which have been coming it out also. So that also relatively depends on the industry wise, and they have been they want to create some dashboards and so on. So they can able to use that Power BI and Tableaus which have been much required also. Okay, so it depends on their scenario basis and so on. Okay, so that also you can able to try it out. Okay, so relatively you can able to specify and you can able to differentiate that also. Okay, so specifically. Right. So, okay. Fine. So I think most of the things like relatively for visualization for those particular data set you can be able to try. So any doubts we'll have some discussion now. So relatively you can have some Any questions if you want to mention it out, so we have some discussion. So let's say. And one more thing. So, I was trying to mention about it. Um, like standardization, we have been specifying, right? So, relatively, standardization we would be required actually. So, because previous we have been specifying about those correlation and all, right? So, at the time of correlation, so what happens? It will be a kind of scenario where your between two columns will be different. Okay, so between the two columns which you're trying to get, it will be totally a different one. So we try to consider. So at that time, we can able to have some kind of relationship. So importance between the two columns and how much nearby values you can able to gather and so on. So this normalization, standard scalars, this kind of pre-processing techniques we used to mention it out. So that relatively would be required. So we can able to use it out, and then it will be much relatively high in value. Okay, so that we can able to apply it out also. So those have the techniques with the relative like scale learn and pre-processing techniques, and those we can able to apply it out also. So those are data normalizations we used to mention. So especially for the yield and even the quality. So those both we can able to apply it out. So that relatively will be C. And for outliers, already with the box plot we have been seeing. So outliers when we have been mentioning. So these are far away values. Okay, so far away values, we can able to remove those values also. So relatively, I'll just show you the function wise how to remove. I'll just try to apply and show you. So you can able to try it out also. So we have the SciPy library. Okay, so scientific Python you can able to say. So scientific Python we can use stats as a function. So this to remove the and so like in just remove those outliers which have been present and so on. As when you're trying to apply removing those outliers, so that it will be a little bit expanding those box plots as the percentage will be changing. So your quartiles 25%, 50, 75 will be keep on changing. Okay, so it depends on the data. So that we can do. Normalizing, okay, how do you find normalize and apply for yield and quality column? Normalizing, you can use your standardized scalars. Okay, so for those two columns, you can apply your scaling technique, and then you can able to apply it into a standardization way. Okay, so then the values would be changing. Okay, so it depends on the multiple scalars are being present. Min scalar, min to max scalar, standard scalar is there. So it depends on that, and we can able to change those two context columns. Okay, so for standardization or normalization technique when I'm trying to use it. Okay, so right, so coming back to this, so Z score, actually Z scores is for the relatively a kind of a part of converting those values. Okay, so and numpy dot absolute stats dot Z score data dot select underscore data types. I'm trying to take it, and I want to include that numbers. Okay, so normal numbers should be able to take it. So by dot number, and we can able to filter some variable name. So Z scores we need to have some range. Okay, so Z score when I'm trying to give it, so between the -3 to +3 range we used to take it. So greater than 3 dot all, already absolute we have been used, so access equal to 1. Because all the columns I'm trying to filter out the data. And data equal to data dot filtered entries filter. It should work. Print data. Okay, so NumPy we didn't include. Okay. Mm, But some of the values have been removed. Okay, so you can see here like 970, then 976 were been there, right? So number of rows. So now you can select total number of rows is 949. So some of the outliers kind of values have been removed. Even after removing, some of the outliers still will be present because the percentage of those interquartile range they have it out, right? So it will be differing. So it will be changing. So again, when they've been calculated, so it will be changing, then it will be removing it again. So now if we check again, the outliers I've been removing. So what I'm doing, I'm just trying to again execute this Z scores every time when you're trying to execute. So those outliers far away values will be trying to get changed because the range will be differing, right? So range will be changing at the time. So now I can say your okay, even one single outliers also will be changed. That's what. Not one. So till it has been here. So you can select maximum most of the some of the outlays which have been here. So some have been gone. So some have been removed and so on. So nearby values which have been changing. So it has been changed compared to the previous one. So here it was 2682.45. Yes, so some of the values have been gone. So relatively. So this is just a way to remove some of the outliers. Okay, so z score is a one function. Okay, so in stats, z scores is to specify it out mostly a kind of a range beyond +3 and beyond -3. So normal distribution we have it out, right? Any values beyond that range would be taken as an far away value. So outliers is to consider. So this z score as one of the functionality at the time is being required. So because already absolute we have been given, so negative will be converted to positive. Greater than 3 which and all is being present, everything. So for all the columns, considering it, it will be removing and getting the data back. So that's why now you can say 901 rows, almost like 75 rows have been removed as an outliers. For each and every column it has been checking, but mostly yield and quality will be considered because year, location, hybrid, planting because like in kind of category columns, right? So it depends on that. So we can able to ignore those things as well. Fine, but this is the way to standardization kind of and even removing those outliers, especially for using this. For standardization, standard scalars, we can able to apply for yield and quality. Okay, so to normalize that, so you can use your sklearn and pre-processing technique. So if you want to apply it out, you can apply in this way. So like sklearn dot pre-processing import standard scalar. So this is the library actually. Okay, so from sklearn you can able to give it and standard scalars for data yield as well as quality. I want to give it equal to scalar. We are trying to mention it out here, and normally we used to give it as a fit transform. Okay, so fit transform. Okay, so fit transform you're trying to do. So now you can see here the yield and quality. Okay, so the you can say like the values have been changed. So those are the standardized values you can able to mention. The values will be changing it out here. So respectively. Okay, so now you can see a little bit of correlation will be happening in yield and quality. 0.18. Previously it was 0.02. Very less correlation. Now it's like 0.18. Some little bit of importance will be raising. But there are multiple different scalars. Okay, so min max scalars, and depends on that we need to check and we need to apply it out. Okay, so but scaling is nothing but your one column scale value will be different to the other column scale value. Okay, so all the values, your yield will be low and your quality will be high. Just in a simple meaning. Okay, so let's say like age is there and your salary has been present. So age is a different meaning, salary is a different meaning, right? So both are not in the same single scale or single unit. So that we are trying to make it in one particular joint. Okay, so one particular unit you can able to see. So similarly, so yield and quality both are a little bit of different, you can say like in different unit or different scaling. Okay, so representation wise and so on. So we are trying to both combine to one particular scale view. Okay, so that's why this scaling technique, this normalizations and all will be coming into here. Okay, so but these are the more relevant way. Okay, so when you're trying to apply and so on. Okay, so respect to that. Fine. Right. So I'll be sharing this. Okay, so this notebook. Okay, so I hope it was a good relatively we have been applied many charts relatively for understanding wise of analyzing that meaning. So we have been seeing that. Okay, so further even maybe in our upcoming sessions view. So we'll be seeing we have the different relatively nodes and let's upgrade. So we have the relevant concepts which we used to learn it further and so on, and especially for Python, for data analytics, machine learning. So we do have nodes, we do have the LMS systems and so on. So we can able to gather here when upcoming workshops or even like boot camps we used to conduct. We have relevant stuff, so I think even from our industry standards, multiple industry standards and so on, especially real time. This is actually how we have been gone into this real time of one of the rice production. All right, so data we had it out, so real time view. So similar to that, we have many coming view also. So we'll be seeing that. All right, so anything else relative if you want to ask, you can able to ask. So we'll have a discussions. You can mention the chat, so I'll try to. Okay, so do check the relevant notes. So which has been shared to you also. So you can able to access and you can able to get it. Even I'll be sharing this notebook also and the PPT relevant. So you can able to um, see those stuff, useful stuff, especially to our IT industries which have been working on around the data analytics and even data science specifically and so on. Okay, so be relatively into it. So further on, we'll meet in our upcoming shops and so on, workshops respectively. So you can go through my Medium site also. So relevantly for further on for Python and even for upcoming data analysis and even for the data science and LM also we have been adding into. So it will be later on part with the Let's Upgrade. So I'll have a discussion with that. Okay, so thank you so much, team. So I try to say we have the upcoming Flutter also. So now next 3 days. So relatively you can able to enroll and you can able to see our from Let's Upgrade. Okay, so and good interactions and so on. Okay, so we do that. And thank you so much. And relatively, and it was good interacting with you, everyone. Thank you so much. Yeah.